number 3 is actually one of my favorite problems of all time. It says for some constant r, the graph of the quadratic function f of x equals negative x squared plus 2rx is a parabola with x-intercepts at p and q in vertex v. What is the area of the triangle PQV in terms of r? So, there's certain things that we can conclude about this function, just based on, we don't know what r is, and it doesn't even say if it's positive or negative, it just says it's a constant value. But we can solve everything in this problem in terms of r. So we're just going to treat r like it's some kind of number. I'm not too worried about it. Now, what does this quadratic tell us? It does say negative x squared, so we know that it's going to open downward. So our a value is negative 1. We also know that because we don't have a constant term, we're going to have a root, an x-intercept at 0, 0. And to clarify that a little, what we can do with this function is we can factor out, let's go ahead and factor out a negative x. That way we have the negative 1 in the front, and we have one of your factors of x. X can be divided from here, x can be divided from here. When we factor out a negative, though, we have to remember to take care of our signs. So we're factoring that out. We divide it from this. Negative x squared divided by negative x is going to leave you with just x. Positive 2rx divided by negative x will get rid of the x, but it will make it a negative overall, so minus 2r. So this is just an equivalent way of writing this function. And what I've done is I've written it in what's called intercept form. And so we know that if these are two factors here, we know that if we set those factors equal to 0, we can get the roots of our quadratic. And so this x here really is a negative x. If we set that equal to 0, we get x equals 0. That's one of your roots. It's one of your x-intercepts. Your other x-intercept is at x minus 2r equals 0. You get your other root, which is x equals 2 times r. So these are our roots of this function. Again, we don't really know what r is, but it doesn't really matter. So let's draw a sketch of this. We have an intercept here at 0, 0. We have an intercept, assuming that it's positive and it opens up this direction. If r were a negative number, then of course it would open the other direction, but it really wouldn't matter. Between the two roots is your vertex, and then we don't know the value exactly. We can draw a sketch, and we know it opens downwards. So this is what your parabola looks like. That's the best I can do. This would be P, Q, the vertex called V. Now the question is asking, what is the area of this triangle? I'm going to kind of outline that in red dashed lines here. Triangle PQV. So if you notice, because of how the symmetry works with a parabola, the vertex occurs at the value that's right in between the two roots. And so the height of this red triangle here is the y-coordinate of the vertex. Now, how can we find the x-coordinate of the vertex? Well, as I said before, we have a root over here at 0, 0, and we have a root at 2r, 0. So I said before, the vertex is halfway between these two roots, so it must be at the value half of 2r. Half of 2r is simply r. What I mean is the distance from here to the vertex is r. So we could say the x-coordinate of the vertex is r, and we want to find the y-coordinate of the vertex so that we can get the height of that triangle. The easiest way to find the height of that vertex is to go ahead and plug an r back into this original function, and it'll give us the value at r. So what we're doing is we're going to evaluate f of r. So f of r equals, if we replace all the x's with r's, we get negative, and this is an r squared, plus 2r times r now, because that's not x anymore, we replaced it with r, And then we can simplify this. This is negative r squared plus 2r squared. Okay, combine the like terms, and we just get r squared. So the vertex is at the value r squared. So the height of that triangle is r squared. So now to get the base, we just look at the distance between the two roots. The base of this triangle is 2r, and your area formula is 1/2 the base times the height. So if you plug in those values, you get 1/2. The base is 2r, and the height is r squared. 1/2 times 2 will cancel to 1, so we're left with just r times r squared, and that does raise r to the 3rd power, so the answer is B. Number 4 says, if n is greater than 0 and 9x squared plus kx plus 36 equals the quantity 3x plus n squared for all values of x, what is the value of k minus n? So this looks like a complicated problem, but again, it's sort of like that other problem. We have two things that are equal to each other. So if we know what 3x plus n squared is going to look like if we expand it out, we can sort of compare it to what this is already equal to. So let's go ahead and multiply 3x plus n times 3x plus n. Or, in other words, we square it. 3x n times 3x plus n. I'm going to go ahead and use the FOIL method to expand that. 3x gives you 9x squared. Okay, our middle term is going to be plus 3nx plus 3nx, so plus 6nx. And then n times n, that gives you n squared. Now you can expand that out also by using the property of perfect square trinomial. The first term is a squared, the middle term is 2ab, and the last term is b squared. That's if you're raising a plus b to the 2nd power. So there are shortcuts that you can take. What this problem is telling us is that this expression, 9x squared plus kx plus 36, is always equivalent to this expression, 3x plus n quantity squared. So, because those two are equal, so if you notice, the leading coefficient is the same. It's 9x squared for both, 9x squared. So because of that fact, we know that all the other coefficients need to correspond. So what I mean is, whatever's in this position, the coefficient for x, the value k, is the same value as whatever's in this position next to x. So k is the same as 6n. Now that doesn't tell us too much yet, but we also know that 36 and n squared also have the same value. Now that tells us a whole lot more, because now we only have one variable. So let's go ahead and set that up as an equation. N squared equals 36. If you take the square root of both sides, you do get n equals 6. And note that it wouldn't normally be positive 6 or negative 6, but the problem told us n had to be greater than 0. So n can't be a negative value. So now that we know the value of n, if we go back here to this yellow thing that I've highlighted, let me write that out in red. It's saying that the value 6n is the same as k. And now that we know the value of n as 6, we can calculate k as just 6 times 6, which is 36. The problem is actually asking what's the value of k minus n, so we're doing 36 minus 6, and that gives us 30. D is the answer.